Hello students. In previous classes we have discussed about the electrode potential, electrochemical series and Nernst equation. Today we will discuss about different type of reference electrodes and electrochemical cells and applications of electrochemical cells. So let's start. Standard electrode. A standard electrode is an electrode used in electrochemical reactions when it is necessary to know the potential of the electrode. Necessary to know the potential of the electrode means like if we have developed a new electrode and we want to check the electrode potential of that particular electrode, then how we will determine. So to determine, we want another electrode which is standard electrode and the potential of which is known. Means standard electrodes are having some known electrode potentials. A reference electrode refers to an electrode that has an established electrode potential. Established means known. We have already checked the electrode potential of those particular electrodes. In an electrochemical cell, the reference electrode can be used as half cell. When the reference electrode acts as an half cell, the other half cell's electrode potential can be discovered. Half cell means the electrochemical cells are having two electrodes, one cathode and another one is anode. So these two are placed in different chambers, and the first one, which is having cathode, is known as one half cell, and the another one which is having anode is another half cell. When we connect these two, the complete assembly is known as electrochemical cell. So here the reference electrode is either act as anode or cathode, and the another one, the unknown one, is also act either anode or cathode respectively. So if we attach these two, we can easily calculate or determine the electrode potential of new electrode because we already know the value of electrode potential for the reference electrode. So by this way we can use the standard electrodes or reference electrodes to determine the electrode potential values of other elements. Standard electrodes can be broadly divided into two types: primary standard electrode and secondary standard electrode. Example of primary standard electrode is standard hydrogen electrode. We have already discussed about the standard hydrogen electrode in standard electrode potential determination. The standard hydrogen electrode is having value 0 of electrode potential, and the secondary standard electrodes are having two different examples: saturated calomel electrode and silver chloride electrode. These two are also act as reference electrodes and used to determine the standard electrode potential of other elements, but these two are not having values 0, and the standard electrode potential values of saturated calomel electrode and silver chloride electrode can be determined with the help of standard hydrogen electrode. That's why these two are known as secondary standard electrodes. So by this way the standard electrodes are very useful to determine the value of standard electrode potential of unknown electrodes. Standard hydrogen electrode. Standard hydrogen electrode is basically a system in which hydrogen ion and gaseous hydrogen are present in their standard state. Standard state means the pressure of gas is known and the concentration of H plus ion is known. So that is the standard state. The convention is to designate the cell so that the standard hydrogen electrode is written first. Always the standard hydrogen electrode is written first in the cell. Here the complete reaction is given. The reaction is H2 in gaseous state gives 2H plus in aqueous state plus 2 electrons. This is the complete assembly of standard hydrogen electrode, in which here this is the acid solution and the as hydrogen gas is bubbled through here in the acid solution. A platinum electrode is dipped in the acid solution. This acid is 1 molar HCl solution. So H plus is present inside the solution and H2 we are providing from the outside. These two should be in standard state, means hydrogen at 1 atmospheric pressure and HCl 1 molar concentration. So this is the complete assembly of standard hydrogen electrode, and the value of standard hydrogen electrode is the standard electrode potential value of standard hydrogen electrode is 0. So by this way we can use the standard hydrogen electrode. Standard hydrogen electrode can act as anode and it also act as cathode. It depends upon the tendency of the other unknown element, means the element we want to check the electrode potential. If the element is having tendency to act as cathode, in that case the standard hydrogen electrode will act as anode. If the unknown element is having tendency to act as anode, then standard hydrogen electrode will act as cathode. So by this way the standard hydrogen electrode can check the standard electrode potential of both type of element, whether they are having tendency to get oxidized or they are having tendency to getting reduced. But the standard hydrogen electrode is not very convenient to use in the normal laboratory condition, as it is not a very stable electrode, and every time we have to prepare a new standard hydrogen electrode whenever we want to check the standard electrode potential of some other element. Maintaining the stream of hydrogen at 1 atmospheric pressure is not also easy task. Preparation of solution of acid of 1 molar is time consuming because HCl is not a primary standard and we have to standardize it with some other primary standard. So it will take lots of time. Also, it is not easy to prepare pure hydrogen, and hydrogen has to be handled very carefully as it is inflammable. So by these 4 points you will understand that it is not easy task to use the standard hydrogen electrode in normal lab conditions. So in that case the standard hydrogen electrode is used to only standardize the secondary standard electrodes, and secondary standard electrodes are quite stable, and normally we can use those secondary standard hydrogen electrode in our lab conditions to determine the standard electrode potential of some other unknown elements. So by this way the standard hydrogen electrode are mostly only used to determine the standard electrode potential of secondary standard electrodes. First example of secondary standard electrode is standard Calomel electrode, which is abbreviated as SCE. The standard Calomel electrode is a type of half cell again, in which the electrode is mercury coated with calomel. Calomel is HgCl2 mercury chloride, and the electrolyte which is used in this cell is a solution of potassium chloride and saturated calomel. In the calomel half cell, the overall reaction is given by this reaction. This is the reaction of calomel cell. This is the assembly of the calomel cell, in which a platinum wire is here. The hole is allowed to drainage through the porous plug. Mercury chloride plus KCl, and this is a glass wool. This whole assembly is dipped in the saturated solution of KCl. So this one is the complete assembly of the calomel electrode, mercury and calomel electrode, in which the calomel is used in electrolytic solution and also to coating the mercury. So here the Calomel electrode is represented like this, and the value of electrode potential of Calomel electrode is 0.244 volt. The value is known, so it can act as standard electrode. And if we want to determine the standard electrode potential of some other element, in that case we will connect that half cell with this standard Calomel electrode, and then we can easily calculate the E naught of the total cell. If we know the E naught of the total cell and value of one electrode, then we can easily determine the value of the second electrode. So by this way, the standard Calomel electrode is act as a secondary electrode, and it is very useful in determination of the standard electrode potential of other elements, as it is very stable in normal lab conditions, and we can prepare a permanent standard Calomel electrode. It is not required to prepare again and again as in case of standard hydrogen electrode. Next commonly used secondary standard electrode is silver chloride electrode. This electrode is prepared by dipping a silver rod or silver wire into a saturated solution of potassium chloride over a paste of AgCl. Here, this is the assembly of the silver chloride electrode. Here you can see that a silver wire is here, which is dipped in a solution of AgCl, in a solution of KCl over the AgCl. This is the paste of AgCl. This is the solution of KCl. And this silver wire is also having some AgCl paste over it. So a silver wire which is coated with AgCl paste, and it is dipped in a solution of KCl over the AgCl paste. By this way, the complete silver chloride electrode is prepared, and it is housed in a glass tube. This electrode is very stable in laboratory condition, and it can be used easily. The complete cell is given by this, and the electrode reaction is this. So a silver electrode is made by using the silver chloride paste, silver wire, and KCl solution. These three things are required. The value of standard electrode potential of this silver chloride electrode can be determined by coupling it with the standard Calomel electrode. This is the complete cell assembly when it is attached with the Calomel electrode. This one is for, the first one is for Calomel electrode, and the second one is for silver electrode, and this complete one is a assembly. Now the EMF of this complete cell can be measured potentiometrically, and it was found 0.56 volt at 25 degrees centigrade. So we can put the values, because we know the value of Calomel electrode, we know the value of complete cell, so obviously we can determine the value of silver chloride electrode. Here E naught cell is equals to E naught R minus E naught L, R means right, L means left. Here the value of cell is 0.56 is equals to E for silver and 0.2422, which is the value of Calomel, and then we can calculate the value of this complete cell, which comes 0.8022 volt. Means the value of silver chloride electrode is 0.8022. Now we know the value, so it will act as standard electrode, and it is very stable. Now a question, I'm sure that a question is in your mind that like this we can use any element or a combination as a standard electrode, but no, because we want a stable electrode. All elements does not give a stable electrode. These two secondary standard electrodes are very stable in a lab condition. Stable means these can be used for a long time in lab conditions, They will not change their nature, and also the standard value of potential will not going to change for after a long time. Only when the electrodes will break or the solution, electrolyte solution, if dries, then the values will be changed, and then the electrode will not be useful for us. But these two are very stable and are very commonly used in all the labs to determine the standard electrode potential of unknown electrodes, and for different chemical reactions to determine the endpoint of different chemical reactions in potentiometric titrations. These are used very frequently. Electrochemical cell. Electrochemical cells are assemblies in which the either chemical reaction is used to generate some electricity, or the electricity is used to energize some chemical reaction. These two things are different, and on the basis of these two, the electrochemical cells can be divided into two types: galvanic cell and electrolytic cell. According to thermodynamics, the reactions are of two types. Either the reactions are spontaneous or non-spontaneous, feasible or not feasible. In case of spontaneous reaction, the reactants are converted into the product and electrical energy. Whereas in non-spontaneous reaction, the electrical energy and products will be converted into the reactants. Means due to electrical energy, the products will be break into the reactants, which happen in case of electrolytic cell. So the galvanic cell is transform the energy released by spontaneous redox reaction into electrical energy that can be used for work. And the oxidative and reductive half reactions usually occur in separate compartments that are connected by external circuit. But in case of electrolytic cell, in electrolytic cell, an external source of electrical energy is used to generate a potential difference between the electrodes that force electron to flow. Means the external electrical energy generates some potential difference, and that potential difference force the electrons to flow into the circuit, deriving a non-spontaneous redox reaction. Only a single compartment is used in case of electrolytic cell. So the major difference that in case of galvanic cell, first the electrode potential is developed, and then due to this electrode potential, the electrons will flow to a outer circuit. But in case of electrolytic cell, the electrical energy provided to the electrode, due to this electrical energy, some chemical reaction happens, and after that chemical reaction, the electrons are going into the circuit. So in case of electrolytic cell, it is a non-spontaneous reaction, and in case of galvanic cell, it is a spontaneous reaction. Here the diagram for the galvanic cell and electrolytic cells are given here. This one is for galvanic cell and this one is for electrolytic cell. In case of galvanic cell, the oxidation and reduction reactions occurs in different chambers or different compartments. These two compartments can be joined with the help of a salt bridge, or can be separated with the help of a semi-permeable membrane. Like in this, a semi-permeable membrane is here. In some cases, a salt bridge is there to connect the solutions to complete the circuit only. So we can use either a semi-permeable membrane to separate the oxidation chamber and reduction chamber, or we can use a salt bridge also if the reaction happens in a totally different chambers. So this one is galvanic cell, this one is electrochemical cell, and the galvanic cell provide electricity, whereas the electrolytic cell uses the electricity. In both cases, the oxidation occurs at anode, the reduction occurs at cathode. In both cases, cathode is on right side, anode is on left side. Only the major difference is that the sign will be changed. The sign for anode is negative and cathode is positive for galvanic cell, whereas in electrolytic cell, the sign is negative at cathode and positive as anode. This happens because the movement of electron is due to different reasons. That in case of electrolytic cell, the electricity is provided, then the electrical potential is developed and the electrons will move, whereas in galvanic cell the electrode potential is developed first, which pushes the electron to the external circuit. So the sign will change totally in case of anode and cathode, but the function at anode and cathode will not change. Always reduction occur at cathode and oxidation occur at anode. Another major difference is galvanic cell. In case of galvanic cell, the reduction and oxidation reaction occur in different chamber, whereas in electrolytic cell it is in a same chamber. So these two are the major difference in the assembly. And third difference, you already know that this galvanic cell is spontaneous redox reaction, whereas in case of electrolytic cell it is non-spontaneous reaction. In case of galvanic cell, the chemical reaction provides the electrical energy, whereas in electrolytic cell the electrical energy gives the chemical change. It is required for some chemical reactions. So these two are major difference in the galvanic cell and electrolytic cell, and these both cells are known as electrochemical cell. Electrochemical cell means where we deal with the electricity and chemical, and whether the chemical energy is converted into electrical or electrical energy is converted into the chemical energy. And on the basis of that, these electrochemical cells are converted into the two different type of cells, galvanic cell and electrolytic cell. In galvanic cell, the chemical energy is converted into the electrical energy, whereas in electrolytic cell, due to the electrical energy, some chemical changes occurs. So these are two type of electrochemical cells. Next is Daniell cell, which is an example of galvanic cell. The Daniell cell is comprises of two electrodes, anode and cathode. Anode is made up of zinc and cathode is made up of copper, as zinc is having negative electrode potential and copper is having a positive electrode potential. The zinc rod is dipped into the zinc sulfate solution making anode chamber, and copper is dipped into the copper sulfate solution making cathode chamber. These are the oxidation and reduction reactions. This is a net reaction, and this is complete assembly of the Daniell cell. Applications of galvanic cell. Galvanic cells are very useful in day-to-day life to provide electric current, and these are broadly classified into two types: non-rechargeable and rechargeable type galvanic cells. The first three example is of non-rechargeable galvanic cells, in which the first is Laplacian dry cell, which is a very common cells, AA, AAA type batteries, which are used in different type of gadgets, in different remotes, etc. Button battery, which is very commonly used in clocks and wristwatches, etc. And lithium iodine battery, this battery is commonly used in different type of pacemakers. And apart from these three, some rechargeable batteries are also there. In these rechargeable batteries, the first one is nickel cadmium battery, which is a rechargeable battery. The lead acid battery, which is very commonly used in different type of inverters and vehicles, etc. And hydrogen fuel cell. Hydrogen fuel cell is also a type of galvanic cell, and it is not quite very common, but yes, it is used in some applications also. So these are some common applications of galvanic cells which are used in day-to-day life. Applications of electrolytic cell. The main applications of electrolytic cell are recharging a battery, electroplating, and electrolysis. In case of recharging a battery, when we are talking about the rechargeable batteries, initially when battery is giving electricity, that is known as galvanic cell. But after some time, when battery stops giving electricity, in that case a recharging is required. In recharging, the battery is connected to some outer electrical sources, and due to electrical energy, some chemical changes occurs inside the battery. So the charging process is example of electrolytic cell. Then electroplating. In case of electroplating, lots of things are plated by the different type of metals for decorative purposes. Like here some examples are given of different type of watches, cups, cutleries, taps, etc. So for the different decorative purposes or some protective purposes. Protective purposes means to protect the metal from the corrosion. Some decorative or protective purposes the electroplating are used. In case of electroplating, like here example of given, like if you want to plate some object with silver, in that case the object is dipped in a silver nitrate solution. The object is act as cathode and a pure silver rod is act as anode, and when we provide electricity, the Ag is going towards the cathode inside the solution, and it is converted, it is coated the object with the silver. So by this way different type of electroplating done. Third common example is electrolysis. Electrolysis process means we want to break some chemical into its ion or into its component. Like in case of electrolysis of water, the water is converted into the oxygen and hydrogen. So here the electrolysis of water example is given, in which oxygen is produced in anodic chamber, anodic side, where the hydrogen is produced on cathode side. So this is example of electrolysis of water. So these three common examples of the applications of electrolytic cell. This is all for today. I hope you enjoyed the lecture. In next class we will discuss about concentration cell, and we will also solve some numericals based on Nernst equation. Thanks for today, and if you are having any problem in today's lecture, you can contact me via WhatsApp on my number. Thank you again.